Hello, my lovely students. Good morning to each one of you. Hope so you all are fine and enjoying these digital classes nowadays. So, my dear students, welcome to World of Chemistry. This is digital classes, and as we are doing the Unit 3 Electrochemistry. Today, I'm going to tell you about one of the very important topic of this unit, and the maximum question is coming from under this topic. So please pay attention, watch this video full, and try to understand whatever I'm going to tell you. Okay. So this is topic electrode potential, cell potential, EMF and measurement. Okay, so basically I'm going to tell you about the doubts that is there in your mind about the difference between electrode potential, what is the difference between electrode potential, cell potential, EMF, generally where we are using and how we are going to measure it. Okay, this is very important to come to know that how an electrochemical cell, as you know that we are discussing what electrochemical cell. An electrochemical cell is of two type, electrolytic and voltaic. In which electrolytic cell is what? First, let me tell you about the electrochemistry. It is the branch of physical chemistry which deal with the study of conversion of electric energy into chemical energy or vice versa. Okay. So in which kind of cell electric energy is converting into chemical energy, and in which cell chemical energy is converting into electric energy, that is known as electrochemical cell. So electrochemical cell is classified into two type of cell, electrolytic and voltaic, in which electrolytic is electric energy convert into chemical energy. In this case, particularly electric energy converting to chemical energy, and in voltaic galvanic cell, chemical energy is converting into electric energy. Okay, these are our daily life cell, and this is that rechargeable cell which in which electric energy is required to break down the chemical. Okay, so let's understand first the electrode potential before going to start the electrode potential. Generally discuss about the basic chemistry of electrochemical cell. Dear students, in basic electrochemical cell, so here I am going to tell you about electrochemical cell. This is a diagram of electrochemical cell in which electrochemical cell is constructed, made up by two container, two half cell, in which two electrolytes is there. This is zinc sulfate, this is copper sulfate, suppose, and two electrode is immersed in the zinc sulfate, zinc electrode, and copper sulfate, copper electrode. Okay, and these electrode are connected with a wire, and voltmeter is there to measure their cell potential, that is how much volt this cell is going to generate. Okay, and it totally depending upon the concentration and amount of electron transfer from this side to that side. Clear? So basically we studied that basic chemistry of electrochemical cell, in which electrode electrolyte interface is there, mean how many electrons are is transforming from electrolyte to electrode and from one electrode to electrolyte. Okay, so in case of anode, what is happening? Zinc is losing 2 electron from zinc sulfate. First, from zinc sulfate is breaking down into zinc 2 positive plus 2 electron, and these 2 electrons are there in zinc rod, and from this zinc rod it is converting into copper rod through this wire. Okay, and once the once the electrons are transferring from zinc rod to copper rod, it means that zinc rod is losing electron, that's why it is called oxidation, and on the other hand side copper rod is gaining 2 electron, that's why it is called reduction. Because of that, we have studied a redox reaction under this chapter, the some of the part of redox reaction. So in copper the electrons are deposited, and in zinc the electrons are losing. Okay, then from the copper rod the electrons are transferring into the copper sulfate. So try to understand once again. Basically what is happening, electrons are transferring from one part to the other part. At first the electron transfer from the zinc sulfate electrolyte to electrode, this is called electrolyte electrode interface. Then from zinc electrode it is transferring to copper electrode, then it is electrode electrode interface. Then from copper rod it is transferring to copper sulfate electrolyte, then it is called electrode electrolyte interface. Okay, so this transfer of electron, how much transfer of electron is generating how much volt, that is totally depending upon the potential of electrode, that is called electrode potential. So potential difference developed between electrode, it is the basically potential difference that is developed between two electrode, cathode or anode, and the electrolyte is called electrode potential. So before going to start electrode potential, to try understand electrode potential in better way, we need to just clear first all these terms, because in your book these terms are there and the students are getting confused related to these terms. So first is standard electrode potential. Standard electrode potential is very important. It is used to measure the half cell. Okay, so what is standard electrode? Standard word is a fixed specific value. So here the electrode potential under the condition of unit concentration, mean when we are taking concentration in form of unit, it is certain specific unit, then it is the word used standard. And of all the species in the half cell, it is called standard electrode potential. Okay, whatever half cell, this half cell have how much potential, that if it is specified with the value, suppose 1 mole word we will write here, 1 bar pressure we will write here, it means that that's standard value we are using. Second, cell potential. Cell potential is the difference between two half cell, mean this, and what is the difference between this and this potential in these two half cell, that is called cell potential. It is generally written as E naught cell is equal to E naught cathode minus E naught anode. So E naught cathode minus E naught anode, it means that right minus left is there. This formula is going to be used in future also. So electromotive force, what is electromotive force? It is the potential difference when no current is drawn. It is that potential difference. This is also potential difference, this is also potential difference, this is also potential. This is potential difference when we are taking unit concentration. Try to understand. This is the potential difference between two half cell, and this is the potential difference of that where no current is drawn from the system. It is measured in volt. This is, we are saying 1.1 volt. Whenever question is asked, calculate the electromotive force, it means that your answer should be in volt. Okay, and what is EMF? It is the reduction potential of cathode minus reduction potential of anode. And these electromotive force is totally depending upon the nature of metal. The metal, different metal, this suppose here zinc, here copper, we are using platinum, we are using hydrogen, we are using nickel. So it depends totally on the nature of metal and its sign. Second, it depends upon the concentration of electrolyte. Here suppose we are using zinc sulfate, somewhere we are using HCl, somewhere we will use some other electrolytes. And the third most important factor is temperature, hot, cold, heat, cool. Okay, that's so this is all about cell electropotential. Now electropotential we need to measure, but before going to measurement, study the measurement of electropotential, let's discuss the cell representation. This is also very important, as you know that chemistry, in chemistry the reactions are represented in the form of symbol, but in electrochemistry the reactions are represented with the help of some these vertical lines, these aqueous solid also. So let's understand what is cell representation. Basically it is the way to express reactions occur inside a electrochemical cell. Okay, so before going to let's take example of Daniel cell. Here you can see, dear students, zinc sulfate, zinc in solid, then one line is there, vertical line, then zinc 2 positive, aqueous. So you can see here, when there is no positive negative charge, then we are writing solid. When there is positive charge, some positive charge on the metal, or it is in the form of ion, anion or cation, then it is given here aqueous solution. It means that whenever any electrode is losing electron or gaining electron, it is converting in the form of aqueous, okay, concentration form. So here in this case especially, zinc is losing 2 electrons, so it is oxidation. Copper is gaining 2 electrons, it is called reduction. This you know very well. Okay, so let's understand a little bit more about what is solid, what is liquid. When zinc solid is written, then it means that it is simple electrode, which is rod. When zinc 2 positive or copper 2 positive written, then zinc 2 positive will anode, copper 2 positive is cathode. Okay, and this single line, vertical line, represent the reaction between electrolyte and electrode. It is representing that the reaction in same cell. Suppose we are taking this reaction, the reaction between this electrolyte to this rod is written in the single vertical line. When the reaction is between this half cell to this half cell, then it is written 2 vertical line. Okay, so as this is double vertical line, which shows the reaction between 2 half cell, which is with the help of salt bridge which connect. Okay, and S is solid, simple rod, aqueous is electrode, it is cathode or anode or in concentration form, and somewhere C1 C2 is written, that is the concentration of zinc sulfate, zinc and copper. Okay, so the cell EMF is, now how to compare, we will write how, if we need to compare the E cell, particularly this cell, Daniel cell, what is the cell potential of this Daniel cell? So we need to find out the difference between cathode and anode half cell. So difference between cathode and anode half cell. This is very important. Dear students, again, maximum time students are writing in confusion that left minus right, anode minus cathode. That is wrong. So we need to write E cell is equal to E right hand side minus left hand side, right hand side minus left hand side. Right hand side is cathode, left hand side is anode. So we write cathode minus anode. Hope so you understood. So E cell is equal to E right minus E left, and E copper 2 positive copper minus E zinc 2 positive in case of Daniel cell. Okay, so how to formulate, that is example, I'm taking one example like this way. Whatever example is there in your book, you can do that. So there is formulate the electrochemical cell in which 2 chromium will react with 3 iron and form 2 chromium cation with 3 iron. So it means that we need to find out first redox. Here, from here to here, there is loss of electron. As you can say, there is loss of electron because this side no charge, this side there charge. Here gain of electron is there. So redox reaction is loss of electron and gain of electron. So we need to represent it in cell reaction as chromium losing 3 electron, and iron is getting 2 electron. So chromium, when losing 3 electron, it is losing this much volt, 0.74 volt. Iron is losing minus 0.44 volt. So the reaction is very simple, right minus left. So this minus this we will do, and it is minus 0.04, and it is general subtraction, minus minus is plus, and when it will subtract, it will give 0.30 volt. It means that this particular cell is giving us this much voltage. Okay, this is one way to represent cell representation and to calculate the electrochemical cell, or you can say the cell potential. By using this formula we can calculate cell potential. But now we are going to see the measurement. So for measurement, for the measurement now, if we need to measurement the electrode potential, now you, as you understood the electrode potential or a potential difference. So how to measure the, you know, the measurement of both the half cell, complete cell potential, so you can find out with the help of cell potential. But if we need to calculate the single half cell, in one part of the half cell, either right or either left, then we are using standard hydrogen electrode. As you know that hydrogen electrode potential is 0.00 volt. So to calculate cell potential of EMF of cell, E cell is equal to E right minus E left. This formula we studied already. In order to measure the half cell potential, the other half cell in this set has to be assigned an arbitrary values. Arbitrary value means neutral value. This is done by assigning the potential of 0. This is called standard hydrogen electrode. Why we are using standard hydrogen electrode? Because hydrogen is that kind of electrode. Its voltage is 0.0, and whenever we are going to add or subtract something with 0, it will give the same value. Okay, in this way we can calculate the one side of the half cell. The SHE, which means the standard hydrogen electrode, is written as, like, for example, first let's understand the construction of SHE. Okay, if we will take the construction of SHE, so it is very simple. SHE consists of a platinum electrode coated with a platinum black. The electrode is dipped in a solution 1 molar of H positive ion, and by passing pure H2 gas, which is bubbled through it at 1 bar pressure, the concentration of both the reduced and oxidized form of hydrogen is maintained at unity. So at 298 Kelvin, the EMF is measured by combining the SHE as a cathode or with another half cell as the cathode, will give the standard reduction. If suppose you have anode value, you know anode value. If suppose we are finding copper rod value, so we will connect the copper half cell with this standard hydrogen cell. So when it will be, we are finding the cell potential, the copper is plus 0.34 minus 0, it will remain plus 0.34. Okay, in future we will do this. So it is the working. SHE platinum is reacting with H2 and giving H positive ion. So here question is there, why we are using platinum only? So dear students, that answer of this question is why we are using just only platinum here. So there is some of the reason, like platinum is used as an inert electrode because platinum doesn't participate in the reaction, but platinum provides its surface for reduction or oxidation reaction and for the conduction of electron also. One more question is coming sometime. Can we use gold in place of platinum in the electrode? Yes, we can use gold also, which can be used as an electrode platinum. So platinum, gold and silver are basically electrode, which is inert electrode, and it is helping us into the, it is not itself reacting, it is just helping to reduce and oxidize the that rod. Okay, so generally now with the help of this, sometime question is coming, simply write down the construction and working of standard hydrogen electron. So you can write this full notes in that. I'm going to share this page to you also. And now dear students, when you know how to calculate the cell potential with the help of standard hydrogen electrode, there is one more way to find out the cell potential or the EMF value of cell, that is Nernst equation. Why there is need to calculate with the help of Nernst equation? It is when the concentration of all the species of electrode reaction is not unity. When the concentration of all the electrode is unity, then it's okay, we can find out with the help of standard hydrogen electrode. But it is not the case every time the concentration of species of electrode reaction is unity. So when it is not unity, then this equation is used to find the electrode potential of cell, Nernst equation, which is given by Walther Nernst, 1864 to 1941. He is the German chemist, and he derived an equation of Nernst equation. Equation is this, in which E is any cell of metal ion into metal, and we are finding cell potential. This is E naught. Whatever value we will find, this value we will put here just to calculate, and minus RT upon NF, where R is gas constant, T is temperature, N is number of electron, F is Faraday value, and log it is we can say the log 1 upon metal ion. Okay, now let's understand what is the meaning of this equation. E naught m n plus and m means standard electrode potential. It is standard electrode potential, this electrode potential, okay, measured with standard hydrogen electrode. So whatever value is we are getting, suppose in copper rod, whatever EMF values are there, those EMF values are known. Let me introduce the EMF value a little bit. These are electrochemical series where standard electrode potential is at there. So you can see here in front of all the metal or elements there is some value. These are the value. Suppose in front of hydrogen, if we will see in front of hydrogen the value is 0.00, that is called standard hydrogen value. And if front of copper, if we will see, so in front of copper there is the value, this is the value 0.34, and if in front of zinc we will see, so this is the value minus 0.76. The thing that we need to be see here carefully, that is all the value which is above hydrogen having positive charge, all the value below hydrogen having negative charge. It is like an integer, and what is happening down the group, it is increasing the strength of reducing agent. It means that lithium has the maximum reducing agent, and fluorine have the least reducing agent, whereas fluorine has the highest oxidizing agent and lithium is the lowest oxidizing agent. This side these are metal, and above that there is non-metal. It depends on the electrochemical series strength, okay, generally called EMF. So by keeping EMF in mind, we can calculate. So R is gas constant, the value of R is 8.314 joule Kelvin inverse mole inverse. The value of F is 96487 mole inverse Kelvin yes, Coulomb mole inverse. So dear student, no need to calculate. This is the standard value, universal value already calculated. So you just have to cram these values by putting these values in this equation to calculate the numerical. So temperature in Kelvin is 298 Kelvin. M is concentration of solid metal, and Mn naught is concentration of anode and cathode. Okay. For example, if we will take electrode reaction, suppose electrode is any metal which has cathode or anode. If it is gaining to electron, it will convert into simple metal. So Nernst equation, when E m n positive converting into metal, it is having cell potential minus RT upon NF log m upon n. So this convert when m is 1, if we will take m unity, okay, that we are taking in other case. If m is unity, then it is becoming like 1 upon m. This is all same, m1 upon mn positive also is the. Now let's discuss about the Nernst equation, and we will see how Nernst equation can be used to calculate the cell potential of a general electrochemical cell. So dear students, let's take the simple electrochemical cell. I am taking from the chemical equilibrium, that chapter you have studied in +1 class, in which we have studied that the chemical equilibrium of any reaction can be written in a QC. Okay, so this A and B is reactant, this capital C and D is product, whereas this small a and b is the coefficient. That is, after balancing the reaction you can come to know the number, which number we are writing. This number is helping us to tell about the number of electron also. So Nernst equation, as you know, E cell is equal to E naught cell minus RT upon NF log and Q. Now don't be confused here, you need to notice that the Q is written because Q is the reaction quotient, that is M upon metal rod. Okay, so we can write in place of this M upon M naught plus Mn plus Q. So by converting the natural logarithm, this ln can be converted because it is difficult to calculate. So ln can be converted into log, whereas ln is equal to 2.303 log. How to calculate log, that one more video I will tell you when we are going to numerical related to log. So E cell is equal to E naught cell minus RT. Everything is same, only in place of Q we are writing now this, as in equilibrium you know Kc is equal to sum of the products of the coefficient of the product upon sum of the reactant coefficients. Okay, and by putting value of RT and F as we did in previous that presentation, so it will put in equation 2. So E cell become E naught cell minus 2.303, this is the value of log, 8.314 is the value of R, 298 is temperature, N is number of electron, and 96487 is F. By putting all these value, when we are taking it in room temperature at 298 Kelvin, then the whole equation after calculating, you can calculate with the help of calculator also, it will come approximately 0.059. Okay, so now in place of this we will write this. We are going to simplify the equation, and in place of now this we will write again from where 1.mn plus. Okay, so now we will use this equation to calculate the numerical. So let's take an example of some of the numerical. First we will take in case of Daniell cell. Daniell cell, you know very well, E in copper, when one half cell is E copper, which is called cathode. This is cathode, and other one is anode. Okay, so you know very well the reaction is cathode minus anode, right minus left. So value of E cathode is in case of Nernst equation, E copper to positive copper minus RT 2F log n 1 per copper. In case of copper we will write copper, in case of zinc we will write zinc. The rest is same. Okay, so when we are putting these values here, we are getting this minus this. Okay, in which RT 2F is the common. Okay, and this is becoming E cell, E naught cell potential. This is becoming minus RT upon 2F, and 1 upon copper 2 positive, 1 upon copper zinc positive. These all will going to be cancelled. It becomes zinc 2 positive upon copper 2 positive. Okay, so the value can be written: E cell is equal to E naught cell minus 0.059 upon 2 log zinc 2 positive upon copper 2 positive. Now we should know the value of zinc 2 positive and copper 2 positive. By putting this value, we can calculate the E cell. Okay, now we are calculating. We are not calculating cell potential. We are calculating now complete that equation, that voltage of that particular cell. Okay, so calculate EMF of the following cell at 25 degrees Celsius. Let's take the example. This is given in your NCERT book also. Iron is converting iron to positive at 0.01 mole. H positive is converting H to 0.01 mole. Okay, so as per that EMF series, which table we have discussed, as per that, E naught is iron to positive converting to iron is taking minus 0.44 volt, whereas E naught H positive into H2 is 0.00 volt. Okay, so you know about cell reaction. This you know very well, right minus left. So right side the value is 0 volt, and left side it is minus 0.04. It becomes 0.44 volt. Now this is the value of cell potential. Okay, so the Nernst equation, when we are using Nernst equation in this cell, so the formula of Nernst equation is E cell is equal to E naught cell minus 0.059 upon n. Now you know, I think better, hope so you better understood now what from where this value came. Log iron to positive upon H positive 2 times. Okay, because the value is 2, so we will write it square. So 0.44. Acha, here also, dear students, one confusion if it is there, so let me clear that. The 2 positive inside the whole bracket mean number of electron, and this after whole bracket square, this is square, this is 2 positive. 2 positive mean 2 electron removed from iron. This square mean 2 time is there. Okay, this is the difference basically. So 0.HH voltage minus 0.059 upon 2 log 0.01 volt upon 0.01 volt. This value is given here, so it is twice a time. When we calculate 0.44 volt minus everything is same, thus just you need to calculate this step. We are converting this into scientific notation, decimal converting into scientific notation. There are 3 digits after decimal, it means that 10 raised to power minus 3. There are 2 digits, it means that 10 raised to power minus 2. Okay, when 2 2s are 4, 10 raised to power minus 4, it means that we will cut, it will come 1 upon 10 raised to power minus 1, and when we will take it up, it will become simple 10. So the formula become now 0.44 volt is equal to 0. This cut 0.2955 log. Now we are coming, we are getting log 10. Log 10 is always equal to 1. So it means that 0.44 minus this, it is coming 0.4105, which is approximately can be written 0.41 volt. So it means that this particular cell is generating this much voltage. Now what is this? These numericals are here. When, dear students, I think you remember that in the first video of this chapter I told you, whatever general cell you are using, suppose you are using Eveready cell or Dura cell, so you can see, we can find that all type of cell is pencil cell, but the potential is different. Suppose Eveready having less potential, Dura cell has more potential. So what is that potential? That is called voltage. So that cell potential we are calculating by using the Nernst equation. Okay, so hope so you understood this video and you enjoyed this video. Feel free to ask me if any doubt is there, and till my next video, take care, stay home, stay safe, take care of your family also. So thank you, thanks for watching this video. Thank you.